Hello everyone, you're welcome to AllMaths with Faye. In today's video, I'll be teaching you how to convert an hexadecimal number to base 10. An hexadecimal number simply refers to any number in base 16. Previously, I've explained how to convert a number from any given base to base 10. We follow these procedures. You first identify the digits of the number you want to convert and their position. Then you multiply each digit by the base raised to the power of the position. And this time around, we're counting the position from the right to the left, starting at 0. Then you sum these results together. We're still following this procedure in this hexadecimal example. And if you have not seen that video of how to convert a number from any given base to base 10, I'll be dropping the link in the description box. So let's dive in. For this example, we're converting 12D, an hexadecimal number, to base 10. So the first step here is to recognize your digits. And what are the digits here? We have 1, 2, and D. Now, this is where the question is coming. How do we say an alphabet D is a digit? I also have a video where I explain the introduction to number base. If you have not seen that video, I'll also be dropping the link in the description box. But this will also help any base that is higher than 10. For instance, base 11. For base 11, the maximum digit that is recognized in base 11 is 10. The maximum digit that's recognized in base 12 is 11, and so on. So let's come to hexadecimal, base 16. The maximum digit that is recognized in base 16 is actually 15. Now, to avoid the visual distraction of treating, all these numbers, 10, is actually like a 2-digit number. So how come you're telling me I should treat it as 1 digit? So to avoid that visual distraction, that is why we do represent them with alphabet. So what I'm saying is, in base 16, your A here is actually representing 10, because 10, 11, 12, 13, 14, 15 are being treated as a digit. You treat them like you don't treat 10 as 1 and 0. As far as bases that are higher than 10 is concerned, you treat them as 1 digit. That's how it's treated for numbers with bases ahead. Meaning that A here is actually representing 10, B is representing 11, C is representing 12, D is standing in for 13, E is 14, and F is representing what? 15 in hexadecimal. All these 2-digit number in our normal everyday math, when it comes to base 16, they are treated as 1 digit. Back to our example. So here we know that this D here is actually standing in for 13. So let's go straight to our solution. So we're having 1. As I said earlier, you multiply by the base you're coming from, which is base 16. Add it together. 2 multiply by 16. Add it together. And this time around, we are no longer having D. We're having what? 13. That's what D is representing here. Multiply by 16. And not just the base raised to the power of the position. I've explained that in some other videos where I treated how to convert from any given base to base 16 to base 10. For this video, I'm just emphasizing on hexadecimal or any base that is greater than 10. This also works perfectly there. So, raised to the power 16 raised to the power of 0, you move towards the left, 1, 2. So if you have more numbers there, you continue with it, raised to the power of 3, raised to the power of 4, and so on. So let's go ahead. If you have gotten this step correctly, as a matter of fact, you have solved this problem 50%. So 1 is multiplying 16 square, which is 16 times 16, 256. Your addition is still intact. 2 multiplied by 16 raised to the power 1, which is 16. Addition is still intact. 13 is multiplying. 16 raised to the power 0, as I do explain, I've explained in my previous video, anything raised to the power 0 is 1. So we have 256 plus 32. Oh, let me write my addition sign clearly. Then plus 13. If you add this together carefully, you should be having 301, which implies that your 12D, a base 16 number, is the same as 301 in base 10. If you follow that example carefully, what you need to know is to know what those alphabets are actually standing in for, as I have explained them here. So if you follow that example carefully and convert this A9, a base 13 number, to base 10, you should be having 139 in base 10. Let me see you play with this. I want to see your feedback in the comment section.